Alright, this is going to be part 5. And we just previously ended part 4 with the laws of addition and multiplication, the commutative law, the associative law, and the distributive law. Now we're going to start with a fresh new topic. We're going to talk about signed operations. And I'm going to start with the easy two. The easiest of the two. And I don't think too many people struggle with multiplying and dividing signed numbers. Okay. So, when doing binary operations, and when I mean binary operations, I'm talking about operations with two numbers. If the signs are the same, the result, the quotient or the product is positive. So if I take a positive number and I multiply it by a positive number, the result is a positive number. If I take a positive number and I divide it by a positive number, the result is a positive number. And if I take a negative number and I multiply it by a negative number, the result is a positive number. And if I take a negative number and I divide it by a negative number, the result is a positive number. Different sign. If the signs are different, the result is negative. So if I take a negative number times a positive number, the result is a negative number. And if I take a negative number and I divide it by a positive number, the result is a negative number. Either way. Whether if this is flipped or these are flipped, they're negative. And we could check this, because if I multiply these two numbers, that means this number divided by this number is this number. Okay, so if these two are multiplied together, this number divided by this number will be this number, and this positive number divided by a negative number is a negative number, which matches this rule. Okay, so the simple way to remember is that when you multiply and you divide, the same sign is always positive, and the different signs are negative. Now, when we talk about adding and subtracting, we start getting something a little bit different. And it works with the same sign and opposite sign too. This is add and subtract. So add and subtract. Okay. So the main thing we need to do here, before I even start talking about same sign, we need to convert all subtractions. Convert all subtractions to addition, and this makes things a little bit easier to follow the rules. So convert all subtractions to addition. So if we have a positive plus a positive, that's one of our situations. We can have a negative plus a positive. That's a situation we can have. We can have a negative plus a negative, and we can have a negative plus, let's see, a positive plus a negative. Okay, so those are the four things, the four different ways that we can permutate this, even if we have subtraction. Okay, so the idea here is if we're adding the same sign, the result is the same sign. Okay, so when we add two negatives, we add, okay, add, and the result is the same sign. Okay, example. Negative 9 plus negative 13. Okay? So we're going to add the absolute values of these numbers because they're the same sign. They're both negative. Same sign means you add their absolute values. So the absolute value of 9 plus the absolute value of 13. So let me write this as the absolute value of 9 plus the absolute value of 13. All negative, and the answer is negative. And that, so we're adding the numbers. 9 and 13 is 22. And because both of these signs are negative, the result is negative. Same as positive. If it was plus 9 plus 13 with no signs, then the result would be 22, positive. Because this is both of these are positive, you add the absolute values, and the result is positive. Now, when they're different signs would be this situation and this situation. Different signs. You subtract. You subtract the two numbers. Subtract the absolute values. Or the number part. Remember, the absolute value is just the number without the sign. So you subtract the absolute values, and the result is the same. The result is the same sign as the larger absolute value. The result is the same sign as the larger absolute value. So let me change this up. Let's do negative 9 plus 13. Okay, so these two are different signs, so that tells us we subtract. So 13 minus 9 is 4, and the larger sign is positive, so we stay with 4. What if we have negative 9? Let me change these numbers up. How about 8 minus 12? Okay, 8 minus 12 would be 8 plus negative 12. So we have different signs, because we converted this to positive. There's a plus between them. And this is a negative, and this is a positive, so that means we subtract, because there's different signs. And 12 minus 8 is 4, and the bigger of these numbers is 12, so the result is negative. How about if we subtract a negative? What if we take negative 4 and we subtract negative 3? Okay, so in doing so, we take negative 4 and subtract means we change this sign. We change this sign to plus. So we're adding the opposite of 3, which is 4 plus 3. Now we have opposite signs. So we do 4 minus 3 is 1, and 4 is the bigger of the number, so it's negative 1. Okay. The best way to get good at this is to practice and find every kind of example that you can challenge yourself with, because you're going to be seeing these for a while. Okay, so that's signed operations. Now let's talk about back to exponents. We're going to talk a little bit more about exponents before we close off here. So if I have a number x to the n, where x is a real number, and for now n is a natural number. Actually, we'll call n a whole number. So n is not a fraction right now. These rules do apply if n is a real number, but I want to keep it a little bit easier for now, because the definition of exponents is a little bit trickier when these are not whole numbers. So this means that I'm taking x and I'm multiplying it by itself n times. Okay. So 2 cubed is 2 multiplied by itself 3 times. B to the 4th is b times b times b times b. And we can combine things. We could say maybe 2 cubed x squared. 2 cubed x squared is 2 times 2 times 2 times x times x. You can combine expressions, and we're going to learn in the next few lectures that this is a term. Okay. X is what is referred to as the base, and n is what is defined to be called the exponent. So, base, exponent. And in the next lecture, I'm going to be discussing laws that apply to these exponents. And for now, I'm going to conclude lecture 5 because it has a lot. The sign numbers really take a lot out of people, and this lecture still follows homework 1, and we'll see you in the next lecture. Thanks for watching.